Dear students, welcome back to another video. And in the previous video, we just talked about chemical equilibrium. I'm continuing with its part 2, and in its part 2, you will study chemical equilibrium state, types of chemical equilibrium states, and what are the macroscopic characteristics of dynamic equilibrium. So let's start the video. Well, you know that equilibrium is all about balance. So in chemical equilibrium state, what do you come to know? Like, what is the type of state is it? So when the rate of the forward reaction is equal to the rate of reverse reaction, and what is the condition? The composition of the reaction mixture, it remains constant. The speed initially changes for both the reactants to react and for the products to form, and then from the products, when you are recovering your reactants, then the speed is changing, but there will be a time reached when the rate, that is the speed or the velocity of the reaction, it will be uniform. So the composition of the reaction mixture remains constant, so it is called a chemical equilibrium state. Now, how many types of chemical equilibrium states are there? So there are two: static equilibrium and the dynamic equilibrium. Like static equilibrium, as the name is indicating, something is stopped. So when a reaction ceases to proceed, that is, it stops, is just the reactants have reacted together and they have formed the product. Now the reaction is over. So I hope that you must be recalling the concept of irreversible reaction. So you are thinking right. This state of equilibrium is the static equilibrium, in which all the reactants have been consumed and they have formed the product, and now no change is occurring. So the reaction is stopped. You can examine this state of equilibrium, that is static equilibrium, in physical phenomenon. So I have added an example here from the book. A building remains standing rather than falling down because all the forces acting on it are balanced. So, when the building is static, but the forces are acting, temperature conditions, pressure, and there are so many forces are present in the surrounding of the building. So they are nullifying each other, and the system is static. That is, the equilibrium is static. In the other form, that is dynamic equilibrium, the property of this is when reaction does not stop. It is a continuous process. It never stops. The products are being formed, and then they are also splitting, decomposing, and they are recovering the reactants. So here you can see this is a reversible reaction, and here the rate of forward reaction is equal to the rate of reverse reaction. I hope that you remember that this sign of arrow, this is indicating that this is a reversible reaction, and it attains dynamic equilibrium. How? First the reactants react, they undergo the forward reaction and give you the products. Under certain conditions, these products, they are reverted to reactants, and this arrow is indicating the reverse reaction. So in case of dynamic equilibrium, reaction is continuous, it is not stopping. However, the rate is changing, but then it will become uniform. However, the amount of these reactants and products will be same in the closed system. I just added another example for your understanding in order to clarify your concept of static equilibrium and dynamic equilibrium. Here you can see on the seesaw, both of them are balancing each other. Both these children are balancing each other, and there is no movement. So this is static equilibrium. This is the physical condition again. Here in the physical condition, the escalator is moving downward while this child is running up the escalator. So he is moving forward while this escalator is moving downward. and this is a continuous process. This is happening, you must have seen it in the malls or any other areas, airports. So this is the example of dynamic equilibrium. This is a physical phenomena. These both are the physical phenomena that are happening in our daily life. Chemically, what? So here, this reaction is in a static equilibrium, as you can see. No reactants are there because reactants have been consumed to form the products, and no movement is there between the reactants and the products. So this is a kind of stationary sort of equilibrium, and this is the static equilibrium. Now to dynamic equilibrium. In this case, as you can see, these reactants are forming the product, and then the product is going back to give you reactants. So this reaction is in dynamic equilibrium because products are being converted to reactants and reactants are being converted to products. This is two-dimensional. It is happening both in the forward direction and in the backwards direction. So this is the dynamic equilibrium. If you want to clarify a concept more in terms of graphs, so here you can see on the x-axis we have taken the time, and here it is the rate of reaction. The speed of reaction is there. So when you know, like when hydrogen reacts with iodine gas, these two gases, if you recall the previous lecture about it, so hydrogen gas when reacts with iodine gas, then it is forming what? Hydrogen iodide, which is also a gas. Okay, so in this case it is a forward reaction. Initially both of these reactants combine together and the process is too speedy, the rate of reaction is very fast, but once they are consumed to make the product, and now product is actually giving them back, so here the reaction is slow. And initially here, when you are just decomposing this hydrogen iodide, or when hydrogen iodide is decomposing, so what happens, initially the rate of reaction is slow, and then it will give you hydrogen iodine gas after the reverse reaction with greater speed. And since it is splitting slowly, so the reactants will move slowly or will react slowly. So here the rate of reaction is going down, while here the splitting of hydrogen iodide into hydrogen and iodine is going up. It is speeding up. So at this point, the forward reaction and the reverse reaction, the rate of reaction is same for both of them. So this is the state of dynamic equilibrium. I hope that you understood it. Now you can compare both the dynamic and static equilibrium. So dynamic equilibrium is reversible in nature and static equilibrium is irreversible in nature. Dynamic equilibrium implies that reactants and the products are still participating in chemical reaction. It means the process is continuous. And in case of static equilibrium, there is no further chemical reaction in the system, so this reaction has stopped. In case of dynamic equilibrium, the forward and the backward reaction rates are equal at a point. And in case of static equilibrium, the forward and backward reaction rates are zero. Since once the reactants are converted into products, there is no further change. The reaction is complete now, and no sort of reactants are there. In case of dynamic equilibrium, it only occurs in closed system, while static equilibrium occurs in both the open and the closed systems. We'll see certain macroscopic characteristics of dynamic equilibrium. Like what are macroscopic characteristics? They are visible to you when you are examining an equilibrium state. So the first characteristic is an equilibrium is achievable only in a closed system. Okay, so the reactants and the products, they are in a closed system. At equilibrium state, a reaction does not stop. Forward and reverse reactions keep on taking place at the same rate but in opposite direction. So here when the equilibrium state is achieved, so Like in case of static equilibrium, we saw the reaction will stop. In case of this equilibrium state of dynamic equilibrium, the reaction is continuous, and forward and reverse reactions are taking place at the same rate, but in the opposite direction. Forward reaction is moving from left to right, and reverse reaction is moving from right to left. At equilibrium state, the amount, that is the concentration of reactants and products, do not change. So you remember that the quantity is constant for both the reactants and the products. And equilibrium state is attainable from either way, that is starting from reactants or from products. So if you go from left to right or right to left, the equilibrium state is attainable from both the sides. The last is, an equilibrium state can be disturbed and again achieved under the given conditions of concentration, pressure, and temperature. So if you are changing this, the concentration of the reactants, or you are changing the pressure and temperature conditions under which the reaction is happening. So if you are disturbing it, the equilibrium state will also be disturbed, but it will be attainable. It will be attainable because once the conditions are met, they are uniform, so you will get the equilibrium state back. So I hope you understood it quite well. Still, if you have any query, you can ask me in the comments, and subscribe to this channel. Thank you.